Hi, I'm Penny and this is Hattie, and this is our Level 3 Probability Distribution Strategy video.
As you probably know, the standard breaks down to 5 main distributions: the binomial, the Poisson, the normal, the triangular, and the uniform. There will also be some questions about expected values, variances, and standard deviations.
In this standard, you'll have a lot of calculations and explanation questions. There's also most likely going to be a question that asks you to compare a graph to a particular distribution.
If you follow the steps in this video, you'll be all set for statistical success.
Before going into the exam, it's probably a good idea to brush up on the rules for all of the 5 distributions. What is it that makes each distribution its own distribution? Another thing to brush up on is your lingo. So what does it mean when a probability is equal to a number? Or what does it mean when a probability is less than or at least a number versus more than or no more than? Another key tip for you is if you have unsure about what probability you're trying to find, is to draw out a number line and label on that number line what it is the question is telling you, and then you're able to figure out what probability you want to figure out.
You know those pesky little formulae under expectation algebra on your formula sheet? Get used to those as well. They're often the first thing you'll cover in class or you'll race through them, but they're actually super important. We'd really recommend checking out the section in your textbook or the StudyTime walkthrough guides on these. Once you've actually calculated your answer, make sure to put your answer in context. So you would never just say P equals 0.1, instead you'd say something more like the probability of a chihuahua weighing over 2 kgs is 0.1. Another common thing for a question to ask is, what assumptions did you make when you were calculating your answer? If you're not sure what assumptions you made, a safe answer is probably independence. Almost all the calculations in this paper assume that events are independent to make the calculations a lot easier, so keep this up your sleeve as a good guess anytime you're lost. Context isn't just for numbers, it's also for those assumptions. So you'll never just say, I assumed independence. Instead you'll say something like, I assumed one chihuahua was independent from another chihuahua. That is, they didn't affect each other. Finally, make sure to also put all your assumptions and justifications for the Poisson and binomial in context. So if you were doing a binomial question about coin flips, you wouldn't just say, there was a fixed number of trials. You'd say, there was a fixed number of trials, that is, 10 coin flips.
Questions will try and trip you up by getting you to use multiple distributions in a row. The best way for you to tackle these questions is to write down what you know and write down what you want to know. While these may seem complicated, almost always the second distribution will be binomial. For example, the first part of the question might ask you to calculate the probability that a chihuahua weighs more than 2 kilos. The second part of the question will then ask you to calculate the probability that the next 5 chihuahuas weigh more than 2 kilos. And then we have our probability of success, which models nicely into the binomial distribution.
A common excellence question is an inverse Poisson question, which is where you're given a probability of a certain number of events happening and you're asked to find the mean, either to use in your answer or to give as your answer. The first thing you need to do for these questions is find the probability of no events happening. Usually in the question it will give you the probability of at least one event happening, so first you'll need to take that probability away from 1 to find the probability that x equals 0. Then look for the Poisson formula on your formula sheet and plug in the probability that x equals 0, simplify away and solve to find the mean.
Another type of question that they may ask you is to compare a theoretical with an observed distribution. The best way for you to tackle this question is to write down in a chart or a table the comparison between the different probabilities in both the different distributions. And then you're able to provide some sort of explanation about how they compare. In your explanations, you should be quite specific with how you describe the difference between the probabilities and quote the actual probabilities. Another thing that you can do to compare the different distributions is to describe the shape. The key to success in this standard is context. Give context with all of your answers. And while we've covered a lot of strategies today, we haven't quite covered everything.
We really recommend going through the past few years of exam papers to make sure you know what to expect, and also looking at the marking schedules to make sure you're writing things in an NCEA style. Textbooks are also a good study resource, but the problem with these is they often give you way more hints about how to answer a question than NCEA does. So to make sure you know how to choose which distribution to use in a particular question, you need to practice doing some questions where they don't tell you. Finally, you can also check out the StudyTime walkthrough guides. They're available for free online or to buy in print, and they're written to help you ace this exam.
Good luck with your exams.